All right, so because of the weather, I just wanted to make sure you guys were all good and I could clarify a few things that I didn't have time to go over in class or maybe didn't sink in as much as I would like. One is that the activity series. The activity series gets people a little bit confused because the activity series is only used for single replacement reactions, only for single replacement. So it's to determine whether a reaction can occur or not. And what you use it for is, if you have, let's say, sodium metal. And remember, sodium metal is going to be the state of matter S for solid. And then you had, let's say, some aqueous calcium sulfate. Okay, and you wanted to know whether this reaction occurs or not. Does it occur? And if it does, predict the products. What you would need to do is look at the activity series. And if sodium is higher on the activity series than calcium, the reaction will occur, because what that means is that sodium metal. So when you look at the activity series, it gives a list of all of the metals, not ions, but metals. And sodium metal wants to be an ion more than calcium. Therefore, it wins. Okay, and so that means that this reaction will occur. So then we would have to predict it. So see, in double displacement reactions, everything's already an ion, so it's not really an issue. It's not really applicable to use the activity series. But here, what you're trying to do is determine whether the sodium metal can jump in and become an ion and replace the calcium. If you find on the activity series you're trying to compare things on two separate lists, like the metal list and the non-metal list, you've goofed up, because non-metals are always anions and metals are always cations, and you have to swap ions of the same charge. So remember that sodium and calcium are both positive ions. Okay, so we're going to piece this together. So now predicting the products. Sodium, when it's an ion, is a 1+, and sulfate right here is a 2-. So when you piece this together, you have to be careful. That means there's going to be 2 sodiums for every 1 sulfate. And if it's aqueous on the reactant side right here, this is probably an ionic compound that's still in solution. These types of states of matter are things that you're going to have to pay attention to and write for single replacement only on the test. Okay, so then if I have a metal and it is in its pure form, neutral, what state of matter are metals typically in? They are solids. Okay, and so that would be the answer to this. And remember that you only use the activity series for single replacement only. And if you were given a question like this where it said if you had these two reactants right here, would it occur? Then you look at the activity series, and if indeed sodium is higher than calcium, the metal or the pure element is higher than the ion, that means it will occur, and this can jump in and replace the calcium, and then you would predict the products. Note the states of matter. You would have to do this. For metals, I'm not going to give you any tricky ones on the test, so assume any metal is going to be a solid. Okay, so that's the activity series. That's the first thing that I wanted to talk about. The second thing is that when you have something like this, that you do need to predict the products. And when do you have to figure out whether it's like the element in its pure form looks like this, or it looks like for instance, sometimes people don't know whether they should write it like this. Okay, I also want to say, what's the difference between this versus this? Well, this right here is saying that you have a calcium that's covalently bound to another calcium. This is just saying that you have 2 calciums, 2 moles of calcium, for instance, in your equation. Oh, by the way, I didn't balance this. I think now it's balanced. Okay, so this is saying I have 2 sodiums. If I wrote Na2, like I have the calcium right here, that is saying that they're covalently bound together. So there is a big difference here. So when does this occur? Okay. So when does that occur? What elements are diatomic? Diatomic means that you're saying like H2 or, is it Ca2? So diatomic molecules are diatomic elements, which means when they are elements in their pure form, they are seen with a subscript are H2, N2, O2, and the halogens. Okay, everything else on the periodic table, you're going to write just like this. You know, it's going to be all by itself, like sodium and calcium, and you'll find that for sulfur, you'll find that for copper, all of the others are like that. Also, these diatomic molecules are gases, so when you write them, they're all going to be like Cl2, that's chlorine gas. Also, hydrogen gas, H2. Okay, so it's not coincidental that all of these guys that are diatomic are also gases. Okay, so watch your states of matter. Most things you aren't going to come into contact with that many states of matter that are liquid, but I do want to emphasize with states of matter, you have your choices between gas, liquid, solid, and aqueous. Okay, remember the difference between these two? What is the difference? Well, if I'm talking about, let's say, copper ions, and they are in water, that means they're dissolved into water. If I talk about liquid copper, a big difference. This one is one that I melted down, and it is like molten liquid metal that I have melted. Sorry about the phone. Okay, so there's a big difference between aqueous and metal. Aqueous means that it is a solution, and liquid means that it is a pure liquid of that substance. Okay, so big difference. And then solids, remember most metals are solids. I'm not going to give any that trick you, but on the test up here, you are going to have to keep track of, you know, if the ionic compound is aqueous here, going to be aqueous here. And the only time I'm going to make you predict states of matter for products is in a single replacement. Okay, so then you'll have to worry about, you know, this type of thing. Is it diatomic? What's the state of matter? If it's a metal, just write that it's solid. I'm not going to trick you with the few exceptions. And if you're trying to figure something else out, you know, majority of the periodic table are solids, but these diatomic molecules right here, remember they are gases. Okay, if you have any questions or you want clarification on that, please, of course, stop by and see me. But these are a few things I just wanted to review with you. Make sure you write these if asked for them. So on the test, if I give these states of matter, if I list them in the reactant side, that means I want them on the product side. If you if I don't state them on the reactant side, that means you don't need them on the product side. And that's it.